Well, hi, good morning. Thanks so much for joining me here in my shop. I'm going to be doing a little bit of work on this Technics receiver amplifier. So this came to me from someone local here in Aurelia who I met a couple of times, and they wanted me just to clean up the controls, the volume control, because it was scratchy. As you know, a lot of these older units get dirt in the volume control potentiometer and you get scratchy results. So that's no problem at all. I told them I don't really, I'm not really set up to work on transistorized equipment, but I can probably solve scratchy volume controls. And I did solve scratchy volume controls. Now there's some risks with taking on this kind of work from people, and unfortunately one of them has come home to roost here. The first risk is, try as I may, I just make the situation worse. I don't think I've done that. But that's a risk with working on this equipment. They bring you something, it's almost 100% working, and next thing you know it's 80% and you can't fix it. That's a risk. People don't want that to happen. Another one is, while you have the unit in your possession, it spontaneously develops a failure. It's just your lucky break that it happened in your shop. When you have to call up the owner and say, didn't the stereo light work when you first brought it over here, because it's not working anymore? And then they say, yeah, it was working. What happened? That's exactly what the situation is with this unit. But the person who's given it to me is very, very kind and just said, well, see what you can do, and it doesn't really matter. I suspect they don't play the receiver on this. They use that as an amplifier. So that's the situation here. Unfortunately, there's another version of this where you're presented with something like this. You're told, the panel lights don't work, and so that's what you're going to fix is the panel lights. That's no problem. But in the course of doing that, you discover that, well, for instance, it won't go into stereo. It won't stereo light won't come on. It won't do it. You call up the owner and you say, hey, did you know the stereo light doesn't work? Oh, yes, it does. No, it doesn't. Well, it did when I gave it to you. Yeah, so that's the risk that people like me, and if you're doing this kind of work, you face these risks too. So I usually try to ameliorate the situation ahead of time. Ameliorate, is that the right word? By making statements about things. So if the worst comes to pass, I've already said something about it. Okay, so what happened with this? When I got it, I'm very sure the stereo light came on. I'm very sure I heard stereo in headphones I was listening with. Very sure. Cleaned up the potentiometers and whatnot. Didn't do very much at all. No stereo left. Let's start with finding out if that's really true. Now I've hooked up two speakers here to it, and so we can hear it. Make sure the volume's down. Make sure there's some power to it. So it's got a little. Actually, this can come right off. This is. You see that? We'll take a look inside in a minute. It's got 3 lights in it. One of them's burned out. The other one's become intermittent. This one's become intermittent here. Uh-oh. Uh-oh. That's not good. Maybe it's burned out. It's these cartridge type light bulbs. 2 of them burned out now. So there's another example. Yeah, but when I gave it to you, you had 2 lights. Now you've only got 1. And I don't have replacements for something like that. Oh boy, going downhill. Volume. Turn on the speakers here. There we are. That's both speakers operating. For an antenna, you see the rabbit ears back here. That's what's being used. So that should be enough to flip this light on. And I can hear it's not in stereo. This is one of the strongest stations here. Not even a whimper. Well, that pretty well proves it. Okay. Okay, so it no longer can detect stereo. So all my troubleshooting skills and stuff like that, and believe me, it's not much around stereo because I don't do too many radios that have a stereo FM feature in them. Let me just turn that light off there. This is not a very old unit. It's got lots of chips in it. You can see one right here. I do have the manual for it. So the approach I want, one more observation. There is one more important observation. This button down here, come back down. Take a look at this. So this button here, FM muting and mode is the name of the button. Top of it says on, FM auto. Bottom of it says off, FM mono. So what is this thing doing? Two different functions. So they didn't say FM stereo up here. They said FM auto. Down here they say FM mono. So I think when they put auto here, what they're trying to say is it will automatically detect and switch to stereo. Which is why they just put mono here. The on and off must be muting, because it's got muting / mode, on / FM auto, off / FM mono. So the muting should be on. I'm going to turn the set back on here. The muting should be on when you have it in. When I have the button pushed in. Let's turn this back on here.
In financing on.
So I'm in between stations now. I have the muting turned on, but it's not muting. No muting. And if I release the button in order to select how these buttons work exactly. Loudness on. Oh, this is definitely confusing. So, here we are. Here's the button indicator. So, button out. You've selected the top. What? I just don't know how to operate this stereo. So that's why the stereo. So you know, I misdiagnosed this entirely. And I know this is a little bright in the camera here. Let's see if I got this absolutely right. You push the button in, and you've picked muting off. That's for sure. And you're in mono, so you'll never see stereo. But when you flip it into auto mode, it doesn't work. Well, I actually had this totally backwards. Holy smokes. Good thing I've checked through this more carefully. Now it's doing something. I can see the meter moving a bit when it crosses powerful stations. It's not enough to break the muting. It's not enough to break the muting and trigger the stereo. It's a weak signal type problem. The other thing I've noticed too is, and you probably noticed, this meter never swings back and forth. It only swings to the right, which suggests to me there's an alignment issue here. So the picture's changed for me from when I came in here. Maybe the next thing to do is just gain some familiarity with how the receiver works, just by looking in the manual a little bit and see what I can cull out of it, especially around this deal here. Right, yeah, let's take a look at the manual. So I've got two pages. I've got this page of information, and then I've got the actual schematic here to look at with some notes down here. I should read these notes right off the bat, because you just never know where the secrets are hidden. Let's zoom in here a bit. Get a look at these notes. This, of course, is just giving you the positions, the way the unit is being operated when you're doing tests on it, or the voltages that are written on the schematic, are done with everything in this position. I don't think there's too much in here that's going to... So you have all these different voltages, and they box them with these different boxes to tell you what voltage you should find under what setting. FM muting circuit operating position. FM muting circuit operating position. FM stereo signal reception. And these are kind of the same thing, aren't they? The same setting? Anyway, schematic may be modified. Yes, okay. Okay, that didn't help us too much. Let's take a look at the, there's kind of some block diagrams here which might be helpful. So here's the first one. FM IF input. AM IF amp. This is the radio right here. FM 2 steps IF amplifier and AM circuit. This is the detector. IF amplifier and detector. IF coming through. Boop, boop, boop. Level detector meter circuit. Oh boy. Quadrature, detector, level detector, muting drive, switching, yay. Oh boy. This is all inside the chip. There's not a lot I can do about any of this. AF amplifier, so that's just the amplifier. What's over here? FM multiplex circuit. Phase lock loop. The stereo indicator coming off of this chip. 19 kilohertz output coming off of this chip. ECO adjustment. I saw that in the back of the unit. This is what it's adjusting. A voltage controlled oscillator. You know what? This is right in the stereo detection type area here. Stereo switching. Stereo switching at 38 kilohertz. Out of the oscillators coming 76 kilohertz. And dividing that down to get to 19. So this isn't crystal controlled, the 76 kilohertz. You got to control it with an adjustment, or maybe this is a small adjustment around a crystal controlled frequency. Phase detector, don't know what that is. Exactly. Locked detector, 38 kilohertz. Left and right output. Stereo indicator lamp. So what would trigger this then? What would trigger this? 19 kilohertz output. So isn't there supposed to be some kind of input here that triggers it, like a 19 kilohertz composite signal input? Composite signal input. Some interesting components just outside of the chip here. Well, this might be really important. My head, this is what they look like. Antenna. Oh, look at that. Antenna coupling. I don't think you spell coupling that way unless you do it in, maybe you spell it that way in Australia? No. Products for Australia. Products for Australia. Coupling capacitors. I guess I like their coupling capacitors in Australia for some reason. Nothing here. Not much here. Power source circuit of other products. What? FM, IF, and yeah, I already looked at this, didn't I? Yeah. Okay. Well, that gives me an idea of what's in here. Why don't we look at the schematic for a little bit? So here's the signal tuning meter. Now, you know, in an older style discrete FM radio, it's easy to find things that you can adjust to recenter this. In here, Oh yeah, there it goes. Goes into here somewhere. Oh my gosh. Maybe there's something labeled here that we can say, it's not, and you know, it's not that the meter is operating off center, something's wrong with the meter, it's that the circuit is out of balance in this receiver, and the detector circuit in particular. It needs to be rebalanced. Well, how the heck do you do that? Oh my gosh, this is not something I'm just not comfortable enough to really poke around with this. Kind of what I'm hoping is, excuse me, I can read these voltages that are posted on here, where all these are voltages here, 2.1, 2.1, 2.1. So I can go along and verify all these voltages. And that's what I'm thinking, that's step one. Maybe that'll get me somewhere. Look how they've written this. Switching. Switching. Oh my gosh. Hey, what's going on? Who's that? Multiplex. Yeah, I think the best I can do is just measure these voltages, and they're very small. Like 1 point, like what? Look at this, 1.9, and over here it's 1.7. And this isn't even connected anywhere. But if I put my voltmeter on there and I read 1.9, what am I to think? That it's wrong? These are just tiny voltages here. I would be looking for a 0, or something that's not appearing when it should. Something like that. Some kind of adjustment here for something. Oh boy. I'm really not hopeful at all on this. But at least now I understand the problem is not what I thought it was. So I've been thinking about the wrong stuff all for the last day or two. The problem is it won't. How did I see the stereo light, and how did I hear stereo with this unit? How did this happen? Or am I just too much confirmation bias in me, and never did do stereo? I'm sure I heard it do stereo. Well, I have a cat here. I have a cat here. Oh, I don't know what I'm going to do with this. Stop and think for a little bit. Go see my cat. Hey, Peanut. Hello. So he doesn't want to go outside. He wants to spend time with me. So I'm going to go spend a little bit of time with him. And think about this before I invest too much time in the wrong direction. I may have already done that. Boy, oh boy, oh boy, oh boy. Oh my gosh. I think I'm going to have to just leave this well enough alone here. I don't think I can solve this one. So the problem I have with this kind of stuff is I just can't leave it alone, for crying out loud. It's been a few hours since the last little bit, and I've spent a fair bit of that time thinking about this guy and also studying the schematic a little more to get a better idea of how it operates. So have a look at this, what I have on my scope here. So that's supposedly a 38 kilohertz signal generated inside the radio. I'm picking it up off of one of the chips. And right now the FM radio is tuned between stations. Can you hear it there? And I'm just going to tune to a station.
Well, daybeds on sale as well.
Okay, as you can see what happened.
Also.
So the oscillator is kind of wandering around a little bit right now. It has no signal to lock on. When I tuned in a station, the station of course is providing a 19 kilohertz signal along with the left and right channel FM program. So 19 kilohertz is grabbed by this radio and all FM radios, and then used to stabilize. It's either used directly or often used to stabilize an oscillator that's supposed to oscillate at 38 like this one, which is double 19, or at 19, and they do other things to get 38, because 38 kilohertz is what what an FM receiver needs to pick apart the incoming signal. There's a couple ways of looking at this, but the easiest way to look at it is the stereo signal that's coming to the FM radio is sending a little bit of left channel and then a little bit of right channel and then a little bit of left channel and back and forth very quickly. You can think of it this way, or it can be thought of that way. And then what the receiver has to do is it has to also switch the signal back and forth from left channel to right channel in perfect coordination with the incoming signal. So the left part always goes left and the right part always goes right. And it's done at a very high frequency, 38 kilohertz. So ultimately there's no notion in a human being's hearing that anything's going on. It just sounds like there's two channels coming, but it is actually doing that. That's one way of looking at it. There's another whole way of looking at it, which is a little more technical and maybe a little more valid, but that's one way of looking at it. So this receiver looks to me like it has a 38 kilohertz oscillator in it. It locks in into a phase, maybe it's a phase lock sort of deal. It locks itself in with the 19 kilohertz signal that's coming in, and then it uses that 38 kilohertz to decode the composite signal. So while I've done all this, I'm kind of, when I'm saying this stuff, I'm kind of reviewing it for my own sake too. What's that mean? Well, it means the receiver is definitely sensitive to picking up a 19 kilohertz signal, a stereo FM signal, and up to this point appears to be doing the right thing. So I'm just going to go look at that schematic a lot more and see if I can't come up with another way to check a little further into the radio where it stops behaving properly. Okay, so on the same chip, I'm now looking at a different terminal, and this should have 19 kilohertz on it. Here's my scope. That's what we see there, and this is with the radio in mono mode. I'll flip it into, I'll push the button for stereo, and you see it stabilized right away. I'm going to tune the radio. Doesn't seem to matter where I tune it. The radio's not performing in this mode, right? It's not doing anything in stereo. It's not doing anything. There's no audio or anything. Although the meter moves a bit right in here. It doesn't do anything to that. That gets stabilized. Turn the volume down. Get a stronger signal here.
You can take someone else who responds to the gospel you share. So, tell someone about Jesus. This is Anne Graham Lotz.
If you're wondering how faith and career fit together, venture on one hand, on the other, the solution may be closer than you.
So that's the 19 kilohertz phase kind of wandering around a little bit.
Turned into practice.
And there it is locked
all
in.
while staying close to home.
Okay.
Redeem.
Just another step. I'm going to try to find the next step. Okay, let's take a look at the schematic at this point. Okay, and I don't want to go into depth. I mean, I've got like an hour staring at this behind me now. I'm not going to spend an hour describing how I got here, but so we've checked this 19 kilohertz. It's there. It seems to stabilize on receiving station. There's another 19 kilohertz signal here internally in the chip. Goes to this phase detector. Out of the phase detector, the signal comes out, goes through a capacitor external to the chip, and back in. Now, right now, I've got the oscilloscope connected, and I'm not absolutely sure one or the other side of this capacitor right here. And what I'm expecting to see is something which would look like a trigger signal. I would think it's an on or off situation. I would just think that it's going to be high or low. It's not going to be like an oscillating signal or something like that. So, and it seems to me that the whole purpose is the signal goes high or low, whichever way, and the result is this trigger thing somehow switches on the stereo switching, turns on the stereo indicator. Something like that. So what we would see here, I think, well, you know, a big capacitor, you can't pass a DC. So it must be a pulse. Maybe it's just a pulse. I don't know. I frankly don't know what's going on. But let's see what's there anyway. I've got the oscilloscope connected right to that spot. And if you want to see it in the circuit diagram here, just for fun. Right, having fun? I'm having lots of fun. Here, wrong chip. This chip, chip 301. This is the part with the capacitor in between. There's the capacitor. Look, it's 50 volt, 0.5, 50 volt. Why electrolytic? 0.47 is easy to do. 0.5. 0.5? I don't know. Maybe because it's smaller, physically smaller than a non-electrolytic one. You know, electrolytic capacitors have their problems. So something comes out of 11 and goes into 10. Is that correct? The other way around. Comes out of 10 and goes into 11. That's interesting because there's a wire coming off of 10. Let's go back and follow that a little bit. This is what I've been doing for hours here. Comes along, goes right into the very switch that I'm pushing. So when you, oh boy, when you push the switch up, you join 1 to 2 and 2. Look, it's the other, hey, it's the other side of this. What? Okay, so it's all related, isn't it? Somehow. Or is that just what, this is just turned, no, the light is turned on with, where's the light? Stereo indicator light on 6. So we look at the stereo indicator light on 6. There it is there. Down it comes, right into the light. Comes out the back. You can get it onto this through a capacitor. Ah, God help me. Okay, let's see what's here anyway. Okay. Now, I'll just put the scope on the screen here. I'll turn the set on. The set is on, Jim. Okay, so I'm going to push that button, basically stereo mono button. Tune a little bit there. Back to stereo. Mono. Stereo. You can see it pop up and pop down. But in the end, it ends up in the same place. So it's not like so perhaps I'm not right. It's not looking for a high or a low to set on or set off the rest of the chip. Any other buttons I can push here or things I can do? Not much other than tuning and stereo. I already did that. Nothing happens. Mono, stereo. So I'm on either 10 or 11, one side or the other of that capacitor. Let me get on the other side. Let me try both sides here. I'm gonna have to. Okay, we'll switch off. Very high likelihood of shorting things while I'm doing this. The ground just come off. Wait a minute, did I have the ground off? I think I did. It's a bad boy. Let's put that back on. 10 or 11. So it's 9, 10, or 11. I'll put it right back where it was. It's on the actually a leg of the capacitor. One leg of the capacitor. Okay. Yeah, let's try that again. Okay. Who says making mistakes isn't fun? Here we go. Okay, so that's obviously it's gone high from where 0 is. And push the button. Same response. I'm looking for any flashing of the stereo light or anything at all. No, nothing. Then I'll do tuning. This is tuning. Okay, I gotta take that little bit of information and look at that schematic some more and see if I can come up with something now. And what am I talking about? I already did come up with something. Let's get on the other side of this capacitor. Got it. Okay, so that's one side. That would be 10. That would be side 10. And what do you look like on side 10? Pin 10. But I didn't short it. Okay, I wasn't looking, so let me just move this here. Okay, now up one division, 2 volts. 2 volts. Okay. We're listening to stereo, so we're hearing nothing. I'll flip to mono. Oh my gosh, look at that. That's exactly what I think should be there. So when you push this button in, that goes low. But I think on the next pin, that's not what happens. There's a big fat capacitor there. Trigger, you know. Trigger, well, I don't know, trigger. I was going to say trigger does suggest a pulse, a trigger pulse, but no, it doesn't. No, you can trigger with a steady high. So, is that the problem? Is the capacitor? That's the most likely conclusion you could reach right now. The problem would be the capacitor. Big fat 50 volt electrolytic capacitor. 0.5. Why not a non-electrolytic? Because, you know, I'll show you. I think I know why it's not a 0.5. I'll get one. So I think the problem is a 0.5 non-electrolytic capacitor looks like that. Hey, this is on, Jim. What are you doing? Don't be dumb. There. Kind of throw parts in. Maybe that'll fix it. So I certainly do have. I've actually become well stocked with parts for doing repairs to machines like this. So I'm certain to have a new capacitor for that. 50 volt, whatever it was. 50 volt 0.5. What if it goes bigger? Now I got to get that out. To get that out, so I have to find out where it is on the board. Of course, it's right next to this chip, which is that's gonna really help. So I can flip it over. It's gonna be the back. It's gonna be the right side of the chip, and I can count the pins. It's kind of in front of past 2. Got all that? Jim, you're speaking in code. Yeah. Okay, flip this over. Make a real mess of everything in my shop. What? I completely lost track of where it was. Okay, so we're gonna flip it over like this. There you go. And now I'm trying to orient myself. It's here. One of the best ways I find is to be pointing at it with your finger you kind of have an inherent idea where your finger is. At least most people do. Okay, so I can point back at my finger. I'm pointing more or less right in here. This is the spot. Somewhere is the capacitor. So here's the chip. And the capacitor was past the jumper right there. That's the capacitor. Look, you can see from 9, 10, or 10, 11 right to it. That's the guy. Can I investigate this capacitor with this chip sitting here? I don't think so. I don't think I should bother. I think I should get it out and replace it, because things have become very hopeful here all of a sudden. All of a sudden. Okay, so I'm going to work on replacing that guy. Okay, so it turns out I've got my choice. I can put a 50 volt 1 microfarad in. I can't do a 0.5. Or I can put in a 160 volt 1 microfarad. You know, since I think the one that's in there has gone defective somehow, it's been beat up by the voltage it's taking. I put the stronger one in. I only have one of these. I have many of these. So let's do that. So I'm going to double the capacitance there. That should just make it twice as good, I would think. Okay, so I've got this clamped onto the capacitor, this thing here. I'm going to pull down with it while I try to desolder. There it goes. Coming right out. There it goes. Okay, I'm going to have to flip this over to put the new one in. Anyway, I got to check the polarity on it. Maybe first we'll give this one a test. Kind of got ruggedized there a little bit. Let's see what happens. Let's try with this. It says it's perfect. Yuck. So it says it's a little under 500 nanofarad. That's a 0.5. And the ESR 6 ohms. I'm not sure what the significance of that is in this case. And the loss is only 0.7. I think this really checks out to be a good capacitor. Somehow I'm not too surprised. So now I got to put this one in. Okay, I'm going to work away at that. Okay, let's do the finish up solder on it. There we go. That's in. Somehow I don't think it's going to make any difference. Okay, let's see what happens this time. Flip this around like this. Giving myself instructions here. Okay, speakers still connected. Let me get my rabbit ears connected with these guys. Okay, the action's going to be on the front panel here. That light, that is where the action lies. To build the we'll to build the tension, we'll start in mono. Mono is in, mono's in. Okay. Okay, no smoke, nothing horrifying. You should not see this light. Ooh. Not the strongest reception. Here we go. FM. So muting comes with stereo. If you have it in stereo, it's muting. So this thing is actually stuck in mute. This is hardly there. There's one. Come on, light, you can do it. Come on. That huffing is my soldering iron. Well, that didn't work. I'm ready to give up again. Yeah. Yeah. Okay, so what I've done now is I've connected the scope to the, you can see it here, to the test point on the same chip 301. That's got the 19 kilohertz on it. That's what we're looking at. And then I've also connected my frequency counter to the same spot. Use the scope to check to see if hooking up the frequency counter was altering the frequency here. It's not. It alters the shape a little bit, but not the frequency. Then there's an adjustment here, the voltage controlled oscillator adjustment, which when I started this was high. This was almost 20 here. 20. And you can see now it's 19. That's where it is. It's where it should be. Doesn't seem to be very locked in though. Of course I don't have, you know what, I don't have stereo on. Oh. Okay, so now I've got stereo on. So we can't hear anything now. Let me tune a little bit here. I don't think you can see that. There's numbers. Okay, so this would be a station right in here. And they just seem to be hanging around 19 now, which is okay. I want them to be exactly 19. So, you know, another approach here would be, oh, the volume's down. Yeah, still nothing there. Ooh, there is something there. The volume's up way high. So it's there, but it's very, very weak. It's not in stereo. It's too weak. It's too weak somewhere to trigger the stereo. But so I'm going to look at the composite signal coming into chip 301. We'll see what that looks like. Okay, so that's a close-up look at the scope connection on pin 2 of the chip, and it's good. Just to show it's not shorting, because I can't really see without the camera, actually. Okay, so So pin 2 is where the composite signal from the earlier detector arrives at this multiplexer chip, or demultiplexer chip. So let's see what that should look like. That should be a much slower kind of audio thing. Good, we're good. Here we go. What happened here? I wasn't looking. Did it jump up? It jumped up, didn't it? Yeah, it jumped up. Okay, let me switch to... Oh my gosh, look at this. So this is what's arriving.
Road Ontario, and when you need relief from unmanageable
Oh, this is a
debt,
big discovery.
we'll help you find the right solution
If I flip
for
it
you.
to
Call us today to book your free no obligation
FM auto,
consultation.
nothing. Is that because of muting? Muting has taken over? That could be why it's in muting mode. I turn it way up, you can still hear it. Because the muting's not 100%, and it doesn't necessarily have to be, I guess. So why is there no input even to the chip, which was still somehow able to stabilize? How could that be? Let me just tune around a bit. It's just nothing going on up there on the scope. But if I put it in... Perfect. Okay, so that's the question. Why is that happening? Okay, I got a good question. That's a good question. I'm going to try to figure that out. Okay, let's take a look at the schematic. So, muting occurs right here on pin 5 of the chip 102. So, they give two voltages here. They give one in the box, which is mono, and then they give one in stereo mode, which is 0 volts. But not really, I don't know if that really clarifies what to expect on this line when it's muted. And then there's a capacitor here, another 50 volt capacitor. The other side here is actually tied to the chassis. I wonder if that was the case with this one too. Which one? This one? No, it was not the case with this one. So what's happening on pin 5 voltage wise? So I'm going to get my voltmeter on there and we're going to see. Okay, so this might get a little awkward here. We're on 5 volts and I want to get on pin number 5 of 102, which is right down here. Pin number 5, so there's 1, 2, 3, 4, 5. Okay, now, can anybody see that meter still? Not really. Okay, here we go. Oops, oops. 1, 2, 3, 4, 5. Okay, that's pin 5. What did it do? It didn't do a thing. I'm going to push some buttons here. Hello, hello, anybody home? Am I doing something wrong? Do I have this? Oh, 1.5 volt scale now. Any voltage set is on? No, I don't have this set on. For crying out loud. That's the problem. Okay, powering on. My hand on it. Come on, baby. Show me some voltage on that meter. Okay, so we're on FM stereo. What? What's happened here? No, we're not in stereo. We're in mono mode. Mono mode. That's why it's not muted. Now I'm going to put it in stereo. What happens? Ah! It's being muted. It's being muted. Oh, maybe it's only tune. It stays muted. So that's the action. back to the other.
That off. This is actually the first time this event has been canceled since World War II.
I can interrupt
We've got
the.
the complete article for you.
I can interrupt the muting voltage on this pin by just cutting it or doing something crazy like that. Just breaking the connection. So it never mutes. Or can I put a ground on it right there and force it to ground? And I shouldn't have left my scope connected during that. Let's just turn this off because of the risk of a short. Let's get it out of there. Okay, that's the question. Why does it stay muted? Now I have to study the schematic again. So if we trace from the muting guy here, we say, why has this guy got voltage? Where's he getting it from? Follow this. Oh, things get a little branchy here. It comes right down into the same switch, the one I'm pushing all the time, mono or stereo. Switch with the muting thing happening. So I have an opportunity to interrupt it at the switch here, probably fairly easily if I want to just break it. It's assuming the voltage is coming from somewhere. Where's it coming from? So maybe I can, let's follow this. This is where it's coming from. There's another 50 volter capacitor, diode. Ooh, this little guy. There's an adjustment here. Let's find this. VR101. VR101 right near this chip. VR101. VR101. Everything's off? Yeah. So VR301, VR this one up here. That one is called, it says separation, VR302. It was 101, wasn't it? I was looking for. Don't say another number. Where is it? Help me find it. So I said it would be near one of those chips. Here, 301. These are fairly easy things to spot normally. Muting. Well, that would be it right there. Muting. Okay, let's try turning that. How do I got to go in there? Oh, awkward. Don't turn it until you're ready. Okay. But still, I need a tool to do it with. Let's stick this big metal screwdriver in there. We're good. Okay. Come around this way. My assumption is I just adjust that until I'm happy about the level of muting, which is okay. So we want to volume down, power on, FM. We're in FM. Mono, stereo. Now it's muted, supposedly. So I'll adjust this muting control. Anything happening here? Almost all the way. The other way. it's all the way the other way. Okay, coming back. Maybe there's a sweet spot? I doubt that. This would be a lovely thing. She just stays muted. Okay, I'll go between stations where there's a hiss. Checking the hiss. Attempting muting, unmuting, muting. So this wouldn't necessarily unmute in any kind of setting. So the muting adjustment doesn't, it's moot. Now we're back to, can't I just get rid of that voltage and make everything happy? And what would be an easy way to do that? Where would be an easy place to interrupt that? I don't know. I'm going to take a look. I'm going to take a little break, I think. Okay, so kind of looking for an easy way out of the situation here. If the case is that for some reason the mute is stuck on, this is kept held high at the wrong time, then if I can interfere with that, then that won't happen. And so just I'm thinking about where it's an easy place to interrupt the voltage supply to this pin. My eye spotted this diode. So if I go to diode 102, which is on the board here, and cut it, I can cut it in such a way that I can solder it back if need be, but I can cut it and find out what goes on. See if that solves this. So I'm going to do that because I think it's not a dangerous shot at this, and the owner has told me he doesn't even care that much if it does stereo with the radio. So now the place where that diode is, if I get it on the camera, yeah, a little hard. Okay, so for what it's worth anyway, the diode is right here. Nip it right on the knee here. D102, that's right. Okay, just lift it up a bit. There. Okay, now did I wreck this thing? Let's see what happens now. That's right, the action will be at the front. If there's any action at all. Volume down. Start with mono. Power on. Okay, it's working. You know what? I could write those songs for crying out loud. Here we go. What happens now? Okay. Hey! Wait 1 second. Oh my gosh. Let's see if this can be made. So I have to watch out for a copyright here. Block the light with my hand. And I can hear it decoding. Well, who knows what the real reason is for this guy not working, but he's working now because I took part of him away. Isn't that funny, eh? Kind of ironic in a sense, isn't it? But there we go. Okay, so thanks a lot for watching this goofy video, and I'm glad it worked out. I'll see you on my next repair journey.